As an example for the magnetic field due to infinite long wires, we say that the figure here shows two long parallel wires carrying current I1 and I2 in opposite directions. I1 here is coming outside the screen and I2 is going inside the screen. What are the magnitudes and direction of the net magnetic field at the point P? Here it can be noted that this angle is 90 degrees and the distance from I2 is R and the distance from I1 is R. So this an equal triangle and the distance between the two wires is D. Alright? Assume that the following values I1 is 15 ampere, I2 is 32 amperes, and the distance D is 5.3 centimeters. Okay, to solve this problem, we are going to apply the rules that we have obtained for infinite long wire. You remember it? In the case of infinite long wire, the magnetic field would be mu naught I over 2 pi R. And the direction of the magnetic field, it would look like a circle, and its direction, it depends on the right hand rule, such that if I put my right thumb in the direction of the current, the other four fingers will be directed toward the direction of the magnetic field. So in the case of the current I1, the current is coming outside the screen. So if we put our thumb such that it's going out from the screen, we will see our four fingers are facing like anti-clockwise. And effectively in this case, it would be normal in this direction. For the case of I2, we will put our thumb of the right hand inside the screen, and we are going to see how our four fingers will rotate. We will find our four fingers rotate clockwise. So the magnetic field due to I2 in this case would be normal to R and in the direction of clockwise. Okay? So we are going to calculate the value of the magnetic field due to I1 and its direction, and the value of the magnetic field due to I2 and its direction, and then by using vector summation we can obtain the total magnetic field at the point P. That's what I'm saying. B1 would equal mu naught I1 over 2 by R, and B2 would be mu naught I2 over 2 by R. And if we want to calculate the value of R from this triangle, we can say that this triangle is normal triangle at the point P. So if we have a normal from B to this diameter D, so the value of R over D would be cosine 45 degrees. So in this case, we can obtain the value of R. R over D would be cosine 45 degrees. Okay, so B1 would be mu naught I1 over 2 by R is D cosine 45, and B2 is similar but with I2. That's the values of B1 and B2. The question now, what is the direction of B1 and B2? As we have mentioned, the direction would be determined by putting our thumb of the right hand in the direction of the current I1, and we will look how our four fingers going here, it would be anti-clockwise. So the field of B1 would be normal to the direction R and is anti-clockwise direction. So B1 would be with 45 degrees opposite to the X direction. So if we analyze these values into X and Y direction, it would be B1X and B1X and B1Y. B1X is B1 cosine 45 in negative X direction, and B1Y would be B1 sine 45 in positive Z direction. B1Y is B1 sine 45 degree in positive Y direction. Okay. For the case of B2, due to the current I2, we will put our right thumb inside the screen and look out for our forefinger. We will see our forefinger is rotating clockwise. So the direction of B2, which is coming from I2, would be normal to the direction R, and it would be clockwise. Once again, we will go to analyze B2 into X component and Y component. Here, the X component of B2 would be B2 multiplied by cosine 45 in positive X. So it is positive B2 cosine 45. And the Y component would be also in positive Y. So B2 cosine 45. Now, by summing the X components, we can obtain the total X component of the total magnetic field. So the total magnetic field in X direction is B1X plus B2X, and B1X is in negative X direction, so it is minus B1 cosine 45 plus B2 in positive X direction, B2 cosine 45. By component will be B1Y plus B2Y, and both of them in positive Y direction. So by taking the amplitudes of B1 and B2 and applying this direction, we can obtain the magnetic field, the total magnetic field in X direction and the total magnetic field in the Y direction. The total value of the magnetic field as a magnitude is the square root of Bx squared plus By squared. And the angle from the X-axis to the direction B is tan minus 1 By over Bx. By applying these values, we can obtain B, the total magnetic field, is 1.89 multiplied by 10 to the power minus 4 Tesla, and the corresponding angle phi would be 70 degrees. It is an assignment for you to make the numerical calculations of this example. Okay?